Let's see for live. Okay. Sorry. Okay. Hello, what is going on, everyone? How are you doing? Hope you all are having a good day. Hope you all are doing great. And yeah, what's up? What's up? What's up? Let me just check once my stream if the voice and everything is okay. If it's okay, we should move forward. And if I go to here, maybe, oh no, sorry, we're here. Okay, seems to be working. So yeah, so I think if someone has followed some of the last sessions, then they would be aware of what we have actually achieved. So just to summarize all of the things and a little bit of summary, I'm just going to go through. And we basically created a socket server using polling, and we were able to receive connections on our server. We were able to receive messages from those clients, those connected connections from our server. We were able to decode the packet header of MQTT packets, and we were able to send back a connect response also once everything was done, once every packet was decoded and we knew that this is a connect packet, and now we need to give them back a response. So, and yeah, so just to be more precise on what we have done, yeah, so I am just going to go through a little bit of about things that we have actually achieved up till now, or it's going to be more of what I have understood, and what I have understood about the technologies and about the mechanisms that we have used in the application to come this far. So a little bit about network, how packets I'm going to be going through a little bit about how network packet transfer, specifically covering the MQTT packet transfer, how it works, and we will not be deep diving into something like TCP or how it generally works and all of that, because I think it takes a different kind of expertise, and I'm not that kind of expert at this time to actually explain the whole workings of TCP. I think there are better videos or content out there that would explain you. So if you're looking for something a more core deep dive into the TCP, then yes, there are much better resources out there also. So yeah, so let's start. So far what we've achieved on the stream is we created a TCP listener server using sockets for C, and sockets are basically kind of an interface, you can say, to do network programming with C. So with socket you can either create your own server or listener, or you can create your own client which will connect to a particular server. Socket gives you the option to lay out your own structure for the kind of connection you will be building. Either it can be on IPv4 or it can be on IPv6, and there are some other parts that you can also tap into if you want to have a more customized solution of your own, where you can just see the sock stream and check the type of network that you want. And there are different ways to play with socket programming also. If you want, you can refer to there's a really great guide out there. You can refer to this guide. It's basically beach.us. It's a socket guide. It tells you, it's kind of a summarized, not a summarized version, but a really great understanding of how socket programming is done through Linux. Obviously there are great books out there, also great resources, but this can work as a start. This can work as a really great start for you if you're just getting into the network programming with C. So yeah. And yeah, so this also covers a lot of other things, like where you how you can receive multiple connections and messages at the same time using IO multiplexing. So IO multiplexing, I will just for a brief scenario, just for a brief explanation, IO multiplexing is a mechanism where you utilize a single thread to handle multiple concurrent input output or IO operation. It can be as simple as that. You don't need another thread for this. You just use a service. In our case, it's going to be the kernel. In our case, it's going to be the kernel for Linux. We just ask the kernel like, hey, please monitor these event parts and for me, and tell me whenever there is any new connection or event happening, just let us know, just inform us, and we're going to look into that. So what happens is, whenever a new event happens on a certain connection that was already connected to us, or maybe someone's trying to connect, so the event is going to happen on our listener itself, the kernel just tells us. And what happens is, uh, it basically gives us kind of like a leverage over here, where we don't need to go into the complexity of managing multiple threads and all of that, and we can just process the message whenever it's arrived, and we would know that there is already some event on that particular client, and then we can just check to see which client has the event. There is an implementation, obviously, if you can see. I'm just going to say int main, and yeah, so what happens is, whenever an event arrives, the poll call over here, this is a blocking call, by the way. -1 sets it to blocking, and we have set it to blocking because I want that kind of nature. So whenever this happens, we just receive the PFD's array is updated, and the R events in this R events property on that listener, or of that element, is updated and set to something like 1 or true. And what we do is, we then just, whenever a call is received, let's say that there is an event that is the kernel tells us that we have received an event. So what we do is, we just go, I've created a function. You can do anywhere you want. I created a function, and we will just loop through the number of FD count. FD count is generally the count of the array that we have, and I will just loop through the count of the array and see which particular element has its R events property set to polling, which means which particular event or which particular element has its value set to polling. That way I know, okay, so this event, this element has an update. Okay, just check to see if this element's file descriptor is equal to listener, which means that there is an event occurring on our listener, which means that someone is trying to connect to our listener, right? So what we do is, we just accept the connection at this particular time. We just accept it. We don't do anything else. We just accept the connection, put it in our array, just add it in our array as a file descriptor. And if not, then that means that some other file descriptor or some other connection is trying to send a message to us. So we just try to process the message. That is what kind of polling IO multiplexing we have achieved. And yeah, so just moving forward into explaining a little bit more about packets, how we have decoded and encoded packets. We're going to strictly stay towards the MQTT packets, and it's a very interesting, it involves a little bit more complexity and understanding. I will try to explain it in the most simpler terms. I'll try my best, but let's see. I'm also, I'm also learning these kind of things, so let's see. So just to see, we're on the part where the connection is made and now wants to send a message. The TCP handshake stuff is already handled, where TCP, when a connection is successful, it also sends some kind of SYN-ACK packets. We will mostly be talking, we're not going to be discussing about more about TCP handshake. TCP handshake is already done. The kernel is already handling that for us. We're going to be discussing more about what happens when a connection is received. And now, because we're strictly towards MQTT, so whenever a connection is received, the handshake is made, and then a packet is sent to our server. So we need to respond back with a packet also, so that the MQTT connection is successfully made. So MQTT is generally a protocol is, you can say, a set of rules that you have to follow in order to achieve its functionality. And MQTT protocol is also built on top of TCP, so any MQTT client can connect to our TCP server using our address. Okay, using our address, they can connect, there would be no problem with that. But on a connection, we have to respond back, them back with an MQTT connect packet. Because MQTT is built on top of TCP, any kind of MQTT connection will be able to at least try for a connection, make a TCP handshake, and then we have to respond back to that MQTT client that, okay, yes, here is your connect packet, here is your connect acknowledgement, we are also an MQTT broker that we're listening, and all of that process, right? So it generally involves kind of sending a packet header. You have to send a packet header, and in the packet header there is a control type, which is the type of the packet that you're trying to send. It can be a connect packet, it can be a connect packet, it can be a subscribe packet, it can be a sub-ACK packet. So whenever a connect packet is received, you have to respond back with a connect packet. Whenever a subscribe packet is received, you have to respond back with a sub-ACK packet, sub-acknowledge packet. And whenever a publish packet is received, you have to respond back with a pub-ACK packet. So after connection, all sorts of packet transfer can happen. So after the connection, all sorts of packet transfer can happen between the client and the server. And the thing here to understand is that even though our server is just a TCP server, we are able to have MQTT connections being connected to us, just because we respond back with the correct rules to the client. Okay, let me re-explain that part. Is because we have a TCP connection with us, we already have a TCP listener with us. All sorts of connection can connect when they're trying to have, like, even an MQTT connection can connect to our TCP server. And what the difference over here is going to be when we're going to define a set of communication rules, which in itself is a protocol. Like HTTP, MQTT are a set of communication rules which in itself create the protocol, and they work on top of TCP. And you just have to define, you can just create your own protocol. You can say that when I have a protocol named 69 69 connections, something like that. You can name your protocol something like that. Okay, and you can just tell the protocol that whenever in my protocol, what's going to happen is whenever a connection arrives, I am going to give them 69 bytes in response, and it has to be done. Only then the connection is going to be made. And you define that rule, you define it, you create the protocol, you manage the packets in that. Somehow your protocol is done. That is only protocol. The communication itself, the TCP connection is already there, made, and it's already being managed by TCP, by your kernel or whatever library or whatever you would be using for that. So for MQTT, the packet transfer is done in bytes, being converted to hexadecimal. If you send, like in MQTT, if you send a hard-coded array of correct hexadecimal, they will just work. Okay, but obviously in a more practical scenario, you have like data being manipulated, so you need to decode the packet first, and according to that packet you have to send back and encode the packet, and that just do the process that way. So firstly, you decode the packet header first, getting control type, like for example control type connect by shifting, like there is a little bit of some things I'm still looking into it, but what I have understood in the packet decoding part, if I'm just going to go over here, is unpack. I'm just going to go to the, yeah, so the packet decoding part, what we're doing is we just unpack this packet header. We have the buff. This buff is the array of the bytes that we have. For example, something like 0x01, 0x02, 0x03, 0x04. These are the bytes, and it's an in we get all of them in an array, something like this: 0x01 and 0x02, 0x03, 0x04. The first, this is the first byte. The first byte itself is the packet header, so we just go through the byte. We shift the bits towards, we shift 4 bits towards the right, so in order to, so we get the correct value of the control type, and then we fetch the lower 4 bits, and yeah, and then we just fetch the flags that are there. Flags can be QoS, quality of service, like is it 1, is it 2, or what kind of whatnot. Okay, and then we calculate the remaining length. The remaining length calculation is already over here. It just goes, it just loops through all of the remaining bytes and see, check for the, if the current bit or the byte has continuation bit set to 1. If the continuation bit is set to 1, that means that there are more bits to follow, and it's going to keep adding the length for remaining length, and that is how it calculates the remaining length. And yeah, so that is mostly it. I think that is all of the things that we have covered up until now, and obviously there is more decoding happening, like packet identifier. You fetch out the packet identifier, you fetch out the you fetch out the topic name, and things like that. You fetch out the payload. If I can show you guys over here, yeah, so over here you can see, we, after we have decoded the packet header, we move towards fetching out, in a subscribe packet we move towards fetching out the topic name, the topic size, what kind, and if there is a payload attached to the this payload part is going to be happening for the more for the publish packet, I think. And for publish packet there is a little bit difference also, and for publish packet we don't need to go for in subscribe packet we're generally going 4 to 4, we're generally going buff plus equals 2, or buff plus equals 4, and then we have the payload, right, and then we have the topic name, right. But for the publish packet we just need to move 2 towards, we just need to move the pointer of the buffer towards 2 ahead. You get the point, right. Buff plus equals to 2, and it's going to do the part for us, no problem. And yeah, and then we can fetch the payload. We're going to work on the payload part today and see how to fetch, decode the payload itself. So yeah, that is generally it. That is going to be kind of the intro for this, and we're going to be deep diving into little bit more into decoding the payload, decoding the also a little bit more into how we are going to be managing the connections, the subscribers, the publish messages, how we're going to publish them to all the connected clients that we have, and things like that. Yeah, so let's start. And I'm just going to do one thing. I'm just going to have this over here, and yeah, a fresh start. We're going to have a fresh start, and I'm just going to turn the music on. So I think the last time mm, okay. So I tried to do a publish packet, and now we receive something like publish packet is received, send back a pubback. Okay. Hmm. So when we have a published packet, for what the first thing that we need to do is something uh, like this, but instead of this we're going to use the pub packet over here, and topic name, let me just see, printf topic name is packet dot topic name. Is this going to work, or is this going to work? Okay. Okay, so we have the topic name. I just need the topic length size. It's going to be this, and packet dot topic size. Okay, topic length size is 16. So if you can see, the problem currently is that we get the topic name, right? We're printing out the topic name, but the problem that is coming is that it just prints out the payload with it also. So we don't need the payload. We just don't need that. We need only the topic name in topic name, and the payload we can parse later on. And so just for this we remove this part where we don't need the packet. We need the packet identifier? I think we would need the packet identifier, but not like this. I need to see how the published packet is actually formed at the time of sending. That way I can maybe look into a little bit more how to send back a response also. So I'm going to do one thing over here, that would be, I have the topic size, so I'm just going to create an array of topic, which is going to be the size of packet dot topic size multiply by 2. Okay, so it's going to be an array of topic, because we need the only the topic name, so we're going to loop through the buff until we just have that. Okay, so I'm just going to do int I is equals to 0, I less than packet dot topic size I plus plus, and we need to do topic I is equals to buff, whatever element is present at buff, just give me that and increase the buff, and keep on iterating until you get that printf the topic name from the topic array, uh, and we can have topic, right? This is fine. Is this compiling us for us min.c? Yeah, seems okay. I'm just going to do topic name from the topic array. Okay, packet type, character, I'm going to do so we're getting 2 elements more. I think this is kind of packet identifier over here, so it's gonna do just going to packet dot topic size, sorry, just going to check we're getting the correct so IoT gateway, some problem with the parsing, I think. memcpy, we have the topic name size, works fine for now. Yeah, I think we have some packet identifier over here. I'm not sure, but I'm still going to just check. So now we have the correct topic name, which is the IoT gateway slash, right? I'm just going to show you also where we have this, and I'm just going to give it new sensors. new sensor slash right. Okay, and we're going to do publish event new sensor slash right. So this is fine. Now we need the payload also. We don't need this. Don't need this. We're just going to do packet dot topic name is equals to topic, and packet dot payload is equals to whatever the buff has for us, right? Okay. Acha, I want to do one more thing is just to verify if we have the correct payload. I'm going to do payload, right? This is payload. Let's just do this, okay? So it seems more relevant to the language itself, because I don't think there is anything. No, but there is. Yes, there are strings. Okay, but not a keyword. Like there is strlen, a helper kind of function, right? Yeah. So I'm going to do this packet dot payload buff, and what's going to happen now is that we're going to print over here the topic name, and we're also going to print the payload now is packet dot payload car. Okay, seems good to me. The payload now is, this is fine, but why at this time, huh? What's this? Is error this time? Why is it mixing up like this? Some reason it's mixing up. I'm just going to do one thing over here then. Print so we have a clear understanding, right? And is there something wrong with the publish? Why send this array? It's this print which is for some reason messing up with this. I'm going to do one more thing. After getting a topic, I need to do. Now it's good, right? No, we're still getting this. I'm going to do to verify this. Right? And printing. I'm just going to check if we have the correct values or not. Packet dot. But as the argument type. How can I print the character itself and loop through there? Can I loop through this or not? I think I can loop through this, but how can I print the character? Like, is there some way to do this? Am I doing something incorrect over here? Yeah, it seems the issue was with this printf itself. So I just removed it, and now the payload is coming fine to me. And this looks fine, right? We have the correct payload. Let's just do seems okay. We need to give back a subak response also. and I need to check. Back packet header, and we're just going to do something like this. Right. Okay, let's just see. Okay, great. So pubback also sent back, and the client accepts it. The client does not throw any error kind of thing, and we have a working publish, subscribe, everything. Yeah. So just to explain a little bit, that this part over here is converting the packet into uh, network endian form, which is I think the big endian. So h turns or mm, h turns, we need to do h turns, or we need to do unpack. This is the unpack part, sorry. I'm not packing anything else, we're just packing the packet header, which is fine. But if we did something like packing the variable, packing the payload, and that would have been a little tricky. Yeah, I think this is fine. If I try to subscribe to a packet, it's fine. It's not giving me anything. Okay, we receive where we respond back with a subac. So we're going to do something like, not the sensors, new sensors, Now we need to manage the connections itself, right? What do I need? What do I need? What do I need? I need to have a there is going to be subscribers which have subscribed, and there are going to be a topic. It's going to be a topic topic will have subscribers added into it. Topic can be multiple also. Okay, topic I'm gonna do something like size size t. Okay, and we're going to do the array, which is going to be the topics array, which is going to have all of the topics inside of it. So I need to create something like a struct of topic, which is going to have something like character to it, which is going to be the name of the topic. It is going to have the subscribers, which is going to be a list of subscribers, and I'm going to do something like struct subscribers. It's going to have subscribers, and I'm going to have subscribers this topic this and topic array this, and this seems fine. I need subscribers is going to have I'm going to just need the file descriptor for that person, and I think yeah, that is fine. It's going to name it topic subscribers array, and it's going to be a pointer, and same goes for topic array. It's going to be a pointer to the array, because we're going to be managing all of these on the heap, so we need the pointers to the array. And yeah, I think this is it. Subscribers is going to have array of subscribers, meaning it's going to have subscribers. Do we need even subscribers like this, or we can just make it so we just find we can do something like this also, right? We just don't need that also. Topic subscribers can be subscribers. It's going to be, because we just need the file descriptors that have connected to it in order to send them a message. Yeah, I think this is also useful. It's kind of a long-term game. Like if I need to manage the connections and see what kind of client does it already have, we can have something like its FD, its name, its kind of keep alive, things like that, so this is also useful. Let's just do the old one, this one, and Yep. Let's see. I need to do not allocating memory for PFDs array, and yeah, what do we need? Just a moment. There is um I can create a pointer to subscribers, I think. It's going to be having a subscribers. What's going to be the size for these? The size for the subscribers I can, because I would need to reallocate this at some point also. So I can do, as a starting point, I can do something like 10, I guess, and like uh, sub is going to be a pointer, right? And we can have subs, uh, an error occurred in allocating memory for the subs array, right? Just have this over here. Now we want an array for topics, right? Topic, and it's going to be TPs. The maximum for topics I can do 10 also. Let's do this 10. Right, and now I can do something like topic array TP is equals to dot size of, right? And there is going to be topic array What does it say? Right, so this seems fine to me, and if I do something like compile it, it seems okay. I can do one thing now, which is going to be add some functions to these, right? I'm also going to send this topic array, and it's going to have no, I did something. Size is going to be 0, right? So if size is 0, that means we need to add at the right TP array are we having I will do sorry TP array dot hmm. TP dot name is going to be doing something wrong. I need to dereference it, right? I'm going to be sending it a pointer to that TP because it's going to be holding the subscribers array also, and it's going to be holding let's do one thing. It can just give me topic array TP array. Okay, what I'm going to do is I'm going to create everything in this function itself, so I don't have to go through the process of creating every single time, and it's going to just mess up the code a little bit also syntactically. So let's just do one thing. Let's just create the topic, and I need to have the name also, like the name for the topic that I would need. I'm just going to do one thing, as I'm just going to go with this. TP is equals to, and TP is equals to malloc, and no, it's going to have if I'm going to create a topic, I would need to I am going to be using it as a pointer, right? To be using it as a, like I already have the topic array on the heap, and now I want to put the element inside of it. But for the in order to put the element inside of it, I get it now. I'm gonna do topic TP is equals to, and I'm going to do something like name, which is going to be name, right? And I'm going to do subscribers dot subscribers array. I'm going to make like a subscribers array on the heap, and it's going to give me subscribers, and it's going to have me like subs is equals to malloc, and it's going to be the size of 10, I guess, which is fine for me. And the this part is going to have topic subscribers array, and I need to have subs placed over here, which is fine. I need to go here, I need to have a size t of sub size. All right, I'm going to go over here, I'm going to just do sub size is equals to 0, just define it as 0. I'm sorry, I have some JavaScript flashbacks. I'm getting JavaScript flashbacks whenever I use the curly braces, because it is so much used in everywhere else. Everything is an object in JavaScript. Every single freaking thing is an object in JavaScript. Anyways, just moving towards yeah, so this is okay. We created a topic, and now we want to put it as an element inside of the topic array itself. We're going to have the topic array, which is going to be TP array, and it's going to have the topic array. We're going to have the TP array dot size, and we're just going to do TP, right? This works. Okay, this works for us, and this is fine, I think. And yeah, it's going to create a topic for us with the name, with the, it's going to insert it into the topic list. It's going to also, I need to do, sorry, I need to increase the size, yeah, like this. Makes sense. And I think we're good to go. And if I go over here, like yeah, TP array, I've already created that. TP's array, do I need this? I need it, yeah, I need the TP's array. Do I need the subscribers, right, like this? I don't think I need the subscribers like this. I just need the TP's array, which is going to be the topic array itself. And add new topic, I'm just going to give it topic, and I'm going to give sensors, something like this, right? Sorry, just do it like this. Yeah, it's going to add a topic sensors for us, and increase the size also. So whenever we have an update, we have a subscribe update, we can do we have a subscribe, we can do something, we can create a function, we can name the function void add new. It's going to have the file descriptor, it's going to have the topic name, it's going to have the what the I'm sorry. So I can do one thing, over here, as I can just loop through what I have. I also need to send it the TP array so that I can loop through it, right? Come on bro, come on. I would need the topic array itself as a pointer so that I can loop through it, right? And see what topics exist, and inside of that topic I can go and put the subscriber inside the element of the inside of the array that we have. So I'm going to pass TP array to process function, right? This is okay, and I'm just going to see the process connection is takes in the topic array pointer to topic array, which is okay. Now it works, and I need to make sure that I also send it TP. It's also going to have a pointer to this, and with this we can have our function, which is right over here, working for int I is equals to 0, I less than tp dot size. Just loop through the topics for me, and you can just go through the topics and print me the topics are, just print me the topics name, god damn it. And yeah, I think this is okay. Sorry, tp dot topic array, this is okay, right? And now whenever we receive a subscribe packet, we unpack everything and we do add new subscriber. We just give it the fd, sorry, we just gave it the fd, and we give it the topic name, which is going to be received when we have unpacked, right? Sub c packet dot topic name, and we gave it the TP array, not the pointer like this. Host void of type car. Okay, let me just change it to will this be okay with you? I think yes. And yeah, let's just see if this works. Forgot to do one thing, we forgot to add, did we add a new topic? We added a new topic. Topics are censored, we're getting the topics are censored, and I'm just going to do something like this also, so we can see. Okay, so if you can see, we have these two new sensors as our topic, and it's being created without any issues. And so sorry, let's just run the music. Okay, this directly comparing them doesn't work. You have to use something like compare. I need to have and try to subscribe and yeah. And there's a problem. We're trying to compare the strings and it gives us, even though we don't have that in our array, it still gives us the response. So these both of the times it's different, but it's still for some reason it's the strcmp is giving 1, which is Okay, I think 0 is used for equal. Hmm. What if we do this topic something like this, maybe just have an effect. We have a warning. Just convert it here. So now this works. The topic that the user is trying to have is not printing anymore because it's not equal, which means we can add our new subscriber over here. We're going to have FD, we're going to have no, this is subscriber function, right? We can do TP topic array, subscribers array, TP topic array, sub size is equals to, do something like this, subscribers. This should do the trick for us. And the topics are equal, we have this, and we can do one thing. After adding, I can just check if it's added or not. Okay, let's just do one thing. So if we do get subscribers, I'm going to get the subscribers for all of the topics. I'm just going to create a loop again where intj is equals to 0 and j is going to be less than tp dot topic array dot subscriber array dot dot subscriber size and j plus plus what dude, what the hell, sorry, this caps lock thing is kind of a bad problem. So I'm just going to print out the subscribers, all of the subscribers that are there, and how we're going to do that is we're going to tp dot topic array dot subscriber array, and from the subscriber array I'm just going to make it j and dot fd, right? And it's going to be inside a printf command. The fds that are connected to topic name, and the topic name is going to come from tp dot topic array dot name, like this. No, not like this. And it's going to have s x/n fd, and it's going to have digit. It's going to have this where right. Seems good to me. So after I've printed or added the subscriber, I want to print out get subscribers, and it's going to have tp definitely. So because there are no subscribers, I'm not going to be printing out anything at the moment. I'm just going to make this so that it gives me something that I have. Send the response, okay. So even though I have the subscribe part, I have the comparison, I have everything, it's not comparing the characters for some reason, and this is a problem. What could be the problem over here? Just a moment. Um, So it is not coming inside this cmp equals 0. Sorry, there has been a problem with this. And send the response, the topic name that the connection is trying to subscribe to. I didn't change anything, right? Let me just print something out. I will print sorry, I'm just trying something with me. So I'm just trying to see if my viw command is working with, like, if I do it something vi and I do something like this. रुक जाओ. Okay guys, give me a minute. Yep, sorry guys. So topic name, I'm going to print it from the So I get the topics are equal. It uh, um, tp dot topic array. Topic array is going to be the I1, and subscriber array is this the correct way to do this? I can make this simpler. I can make this simpler. Topic array, and at the I part I need the subscriber array, and the subscriber array's index is going to be coming from, yes, this is fine, tp dot topic array. At the I part I need to increase the sub size. Okay, this looks fine to me, and I think, yeah, I need it now. Okay. Looping through the subtopic, the connection is in subs, the topic name, looping through the subs. Okay, so it's looping through the subs a single time, and if I'm going to print the topic name, it's going to be this, and if I'm going to print topic, right, okay, so the FD that is the topic name sensor, the FD that is tried to connect is 4. Okay, this seems to be the correct way. This seems to be the correct part of doing this, and I have successfully added a subscriber over to this. And if any new subscriber comes, let's say We try to subscribe again, maybe, I don't know. And so there is no update being coming from this. Why is that? How much lines of I don't receive a packet from the client itself. So the publish works. Publish is going to give me a response. Publish packet is received. New sensors, right. Send the response. This is strange. Some stuff has happened. We send them back a subac, but why? We shouldn't send them a subac. Pubac is fine. Topic name is new sensors. The payload is now topic length size 16. So the topic name is getting messed up also. Okay, I'm going to take a short break and we'll be back. Just a little short break and I'll be back with you guys. Okay.